This is practice exam B for unit 1. Question 1 here is difference quotient from section 2.1. So we'll do this part first, f of x plus h. Let's evaluate that. F x plus h. So I'm going to replace this variable with an empty parenthesis. So instead of x squared, it'll be parentheses squared minus 5. And I'll place x plus h in that parenthesis. And then x plus h squared means you multiply x plus h with itself. If you distribute those two together, you're going to get x squared plus xh plus another xh plus h squared. Subtract 5. So you have two xh terms. Now this right here, minus f of x, that just means we subtract the original function. So we're just going to subtract x squared minus 5. So we're ready to set up the difference quotient. On the top left, we're going to place this expression here, f of x plus h. And then we're going to subtract f of x, so we're subtracting that. And remember, when you subtract a function, you need to subtract the entire function in a parenthesis, and then we divide by h. Now, negative x squared, positive x squared, they're going to cancel. This minus negative 5 becomes a plus 5, which will cancel with that. So x squared, this positive 5 and that negative 5 cancel. So we're left with 2xh plus h squared divided by h. If you factor in h from the numerator, you have 2x plus h. It's left over. So now the h that you factored out simplifies or cancels with the h in the denominator. And final answer is 2x plus h. Find the domain. This is also from section 2.1. For part A, we have square root. Remember, with even numbered roots like square roots or fourth roots, the expression underneath the radical sign has to be greater than or equal to 0. So what I would do, what I recommended, is take that expression, set up an inequality. Now if you subtract 4 on both sides, now divide by negative 1, and remember, when you divide by negative, you flip the direction of the inequality. So what this is saying is your domain x has to be less than or equal to 4. That means 4 is your upper bound, and it's equal to 4, so 4 is going to be my upper bound, and now anything less than that goes all the way down to negative infinity. For part B, we'll factor the denominator into x minus 4 and x plus 3. Now, this tells us that x cannot equal 4 and x cannot equal negative 3. That does also tell us that x can equal, for your domain, x can be anything else except positive 4 and negative 3. So the way we're going to exclude that is by going from negative infinity to negative 3, and then from negative 3 to 4, and then from 4 to infinity. And these are all parentheses, not brackets. All right, question 3 is from section 2.2. What I recommended is for each piece, you make a table of values, an input-output table. So this top piece, for example, I'm going to let x equal negative 3. And you have to remember there, at negative 3, we're going to have a closed circle because it's less than or equal to. So a closed circle at negative 3, and then less than that, we could do negative 4, negative 5. Now, you plug these values into this piece of the function, but the only output value that's possible there is 2, so all the output values are going to be 2. So we have negative 3, comma 2, negative 4, comma 2, negative 5, comma 2, with a closed circle at negative 3, comma 2, and it points to the left, because that's less than negative 3. Now for the middle piece, it says we're going to choose values between negative 3 and positive 1. Now, negative 3, it's strictly greater than negative 3, not greater than or equal to, but I am going to put a point at negative 3. It's just got to be an open circle. And then up to positive 1. And that can be a closed circle because it's equal to when x equals positive 1. Now, if you plug negative 3 in for x, the opposite of negative 3 is 3. 3 plus 1 is 4. And that's an open circle, remember. And then would plug 1 in, the opposite of 1 is negative 1. Negative 1 plus 1 is 0. So negative 3, comma 4 with an open circle, and 1, comma 0 with a filled in circle. Now for this bottom piece, x greater than 1, not greater than or equal to, but I am again going to place a point when x equals 1, and remember that's got to be an open circle. And then greater than 1 would be 2, 3. So plugging in a 1, 2 times 1 is 2, 2 subtract 2 is 0. 1 comma 0. And then 2 times 2 is 4, 4 subtract 2 is 2. And then 3 times 2 is 6, 6 minus 2 is 4. So 1 comma 0, and then 2 comma 2, and 3 comma 4. Looks like that. Okay. This is from section 2.3. Find f of negative 2. So remember, negative 2 is your input value, and we need to find the value of the function when x equals negative 2. So x equals negative 2 right here, the function value is 0. So f of negative 2 is equal to 0. So for part A, f of negative 2 equals 0. For part B, the domain, this arrow means that the graph continues to point up and to the left, which means all of these negative values, you're going to have output values on the graph somewhere way up here. So all the way from negative infinity to 1 with a parenthesis on 1 because the graph is not equal to 1 right there. So the domain is from negative infinity up to positive 1 with a parenthesis. The range is along the y-axis. So this graph continues to point up, which means as far up here on the y-axis, you're going to have a point somewhere over here with that output value. So the upper bound of the range is positive infinity. The lowest value for the range is y equals 0, right there, including 0. So the range includes 0 with a bracket up to positive infinity. Now for part C, this piece of the graph that I'm highlighting in red is decreasing, as is that piece. This piece here is increasing. Remember, we always read a graph from left to right, so going from left to right, the x values are getting bigger, but the y values are decreasing. Now the y values are increasing, y values are decreasing. So the increasing part is the one I've highlighted in blue. And remember, the way you describe this is using x values only. So from x equals negative 2 to x equals 0 is where the graph is increasing. So increase from negative 2 to 0. the graph decreases from negative infinity to negative 2, and again from 0 to 1. Now for part D, is the function 1 to 1. Remember, there's a test if you have a graph. It's the horizontal line test. The graph fails the horizontal line test right here. The function is not 1 to 1. And another question you might want to be prepared for, even though it's not asked on this one, is the local minimum, local extreme values. So there's a local max value right here at the point 0, 4. And there's a little min value right here at the point negative 2, 0. So something to be aware of. You might want to be prepared also, in addition to finding intervals of increase and decrease, to state where you have local minimums or maximum values. Question 5, this is from section 2.4. Average rate of change. Remember, we talked about this phrase, average rate of change is simply slope. Slope is f of b minus f of a divided by b minus a. So what that'll translate into is, we can call this one a and call this one b. So this would be f of 2 minus f of negative 1 divided by 2 minus negative 1. So all we need to do is find f of 2 and f of negative 1. So f of 2, 2 squared is 4. Over here, 2 times 2 is 4. 4 plus 4 is 8. F of negative 1 squared is 1. 2 times negative 1 is negative 2. 1 plus negative 2 is negative 1. So f of 2 we replace with an 8. F of negative 1 we replace with negative 1. 2 subtract negative 1 is 3. 8 subtract negative 1 is 9. 9 divided by 3 is 3. Okay, so this question 6 is from section 2.6. So that minus 2 there represents a vertical shift down 2 units. The plus 1 represents a horizontal shift to the left 1 unit. The 1/3 outside the function represents a vertical compression. And then that negative sign outside the function represents a vertical reflection. That's from section 2.6, as is question number 7 here, 2.6. So what we have here is a square root function. Remember, f of x equals square root of x. That's the parent function. It starts here at 0, 0 and points up and to the right. So what we have to figure out is how is our graph here going to be different. So first place to start is where's the beginning point. Instead of 0, 0, it's 2 units to the right and 2 units up. So there's our starting point. And then we're going to have a vertical reflection and a vertical stretch. So what I'd recommend doing is making a table of values. We already know that there's a point at 2, 2. So plugging in some values for x, I'm going to plug in x equals 3. 3 minus 2 is 1. Square root of 1 is 1. 1 times negative 2 is negative 2. Negative 2 plus 2 is 0. So 3, 0, excuse me, 3, 0 is on the graph. And it looks like it's going to be pointing downwards, which makes sense because we have a vertical reflection. Now I'm going to place x equals 6. 6 may seem like a random number. It's not. 6 subtract 2 is 4. And the square root of 4 is 2. 2 times negative 2 is negative 4. Negative 4 plus 2 is negative 2. So 6 comma negative 2 gives us a graph that looks like that. Question 8 is from 2.7. So for part A, f plus g of 2 could also be thought of as f of 2 plus g of 2. So just need to figure out f of 2. This is 2 over 2 subtract 1. 2 subtract 1 is 1. 2 divided by 1 is 2. So f of 2 is equal to 2. Then we need to find g of 2. G of 2, so we have 2 subtract 2, which is 0, and this is undefined. So that means f of 2 plus g of 2 is undefined. Now for part B, we're subtracting f minus g, which again could be thought of as f of x subtract g of x. So f of x is 2 divided by x minus 1, and we subtract 3 over x minus 2. Now we have to get a common denominator. So the one on the right, I'm going to multiply by x minus 1 over x minus 1. Now this one over here on the left, I'm going to multiply by x minus 2 over x minus 2. So then what we'll have in the numerator over here is 2x minus 4. Over here we're going to have 3x minus 3. And remember, this minus sign has to distribute to that. So we have x minus 2 for x minus 1. When we combine like terms, we have 2x minus 3x, so that's negative x. And then we're going to have negative 4 subtract negative 3. Subtract negative 3 means plus 3, so negative 4 plus 3 is negative 1. Okay, for part C, f times g of x is the same thing as f of x multiplied by g of x. This is a filled in circle. So it's 2 over x minus 1 multiplied by 3. That's a multiply by 3 over x minus 2. Remember, with multiplication, you just multiply straight across. Like that. For part D, we have f divided by g of 1, so that's just f of 1 divided by g of 1. So f of 1, if we plug a 1 in here, we're going to have 1 subtract 1, which is 0, so this one's undefined in the numerator. Denominator, I mean, it really doesn't matter, but if we plug a 1 in here, 1 subtract 2 is negative 1. 3 divided by negative 1 is negative 3. So the point here is this whole thing is undefined. For part E, it is g of f of x so the g function is 3 divided by x minus 2. Now I'm going to turn the x into an empty parenthesis because f of x is going to fill that empty parenthesis, and f of x is 2 over x minus 1. So what we need to do is combine this into one expression, this denominator. So we have 2 over x minus 1, and then this is 2 over 1. So to combine these, we need to get a common denominator of x minus 1 over x minus 1. So we have 2 over x minus 1. I'm doing this denominator here. 2 over x minus 1 minus 2 times x minus 1 over x minus 1. So we have 2x minus 2, and it's going to turn out actually to be a minus negative 2, so that's a plus 2. Let me write this up above. This is going to be 2x minus 2, but it's really subtract negative 2, so it's a plus 2. Plus 2 combined with this 2 is 4, and then we have this negative 2x right here. So this is negative 2x plus 4 over x minus 1. That's what the denominator is. So we have 3 divided by negative 2x plus 4 over x minus 1. So we can change this division problem into a multiply problem. So 3 multiplied by the reciprocal, x minus 1, over negative 2x plus 4. And that equals 3x minus 3 over negative 2x plus 4. Now for part F, which I think I'm running out of room here, the domain of part B, so what we got for part B was negative x minus 1 over x minus 2. Well, I don't need to write it again. The domain is here, or the function is here, x minus 2, and that's an x minus 1. So x cannot equal 1, and x cannot equal 2. So the domain is going to be negative infinity to 1, 1 to 2, 2 to infinity. For part C, we have x cannot equal 1, x cannot equal 2, so same thing. Okay, so we need to find the inverse. So we need to find f of negative 1, and then we need to state the domain and range of both. What this means is both f of x and the inverse of x. So we need to state the domain and range of both of those. So we have our original function. First thing we do is switch the place of x and y. So again, if we want to, we can think about this as y. If we switch the place, now we need to solve for y. Y is at the bottom of a fraction, and if we can avoid it, we want to try to avoid solving equations and things with fractions. So one thing we can do to clear a fraction is multiply both sides by the denominator, because what that will do is clear that fraction over there. So here we have y plus 3 multiplied by x is equal to 2. Now we can divide by x. So then we have y plus 3 is equal to 2 divided by x, and then we could subtract 3. So we have y equals 2 divided by x minus 3, and that's equal to the inverse. Now from the original function, we're excluding negative 3 from the domain, so the domain is going to be from negative infinity to negative 3, and from negative 3 to positive infinity. Now from the inverse down here, the domain is here, x cannot equal 0, so 0 is excluded from the domain, so that's going to be negative infinity to 0, and 0 to infinity. So now, this domain of the f of x becomes the range of the inverse, and this domain of the inverse becomes the range of the original function f of x. Okay, number 10 is from 2.8. To sketch the graph of an inverse, you switch the place of x and y. So what I suggested in class is for the original function f of x, you make a table of values of points that are easy to identify. So like negative 4, comma 3, negative 2, comma negative 1, 0, comma 2, 1, comma 0, and there we have 2, comma 2. So for an inverse, we're going to switch the place of x and y for each point. So we're going to have 3, comma negative 4, negative 1, comma negative 2, 2, comma 0, 0, comma 1, and 2, comma 2. So 3, comma negative 4 puts us right about there. Negative 1, comma negative 2 puts us right there. Actually, let's try that again. Negative 1, comma negative 2 puts us right here, like that. 2, comma 0 puts us there. 0, comma 1 puts us there. And 2, comma 2 puts us right there. And one little visual check you can make is, as we discussed in class, that these inverse functions graphs are a reflection across that line right there.